Aha, we're live. Hey everyone, my name is Nicola Paolucci. I live in Amsterdam. I am Italian. I work for Atlassian. And now you know mostly everything about me. I speak a lot about code collaboration, distributed workflows, and Git, and have been very enthusiastically embracing this Docker craze, and that's why I'm here to talk about it and share my enthusiasm for it. So before I start, easy question. See, yes? Do you guys know what the bus factor or bus number is? Raise your hand if you know. Hey, you know, many hands, nice. So the bus factor is a sort of a joke definition, and it represents a measure of a resilience of a software team. So in plain words, how many people should just fall under a bus before your software project is doomed? And I tell you this because, so a while ago, I was at this meeting with 15, 16 of the top contributors of Docker, including corporate sponsors, the top main core contributors. And as we were coming out of this meeting, we entered an elevator. And somebody made the joke, what would happen if now the elevator had an accident? And the lights went off and the elevator stopped. Last part is a joke, but it actually, we were in an elevator, somebody made the joke, and actually it made me think that, do you recognize this movie, by the way? It's called Debian. It's all about an elevator. And so the point is, Docker has such a great big community that now it's past its core developers, and now there's like 700 contributors. They processed recently like 5,000 pull requests. Well, 3 out of 4 of those have been actually merged or closed and so analyzed. So it's a very thriving community, and even if the top contributors would leave the project, it would still be a thing that's now part of our ecosystem, and it's wonderful. So why is there so much interest and so much participation and enthusiasm for Docker? So I give you my 3-minute introduction about Docker. So first I would like to know who has already played with it. Could you please raise your hand? Okay, so it's a good 15-20% of people. So it's good that I give you a brief refresh introduction about Docker. So what is Docker? Why is everybody very excited about it? Well, first you have to understand that the main problem that Docker tries to tackle, which is deploying applications to the cloud, is a hard problem. It's true, we have standards, we have platforms, we have frameworks, we have technology, and we have a lot of experience in this. And still, it's really hard. Actually, the explosion of technologies, platforms, providers makes it even hard. So there's this explosion of choice that paralyzes you. And so you have to choose a framework, you have to choose a service provider, you have to choose a packaging system. How are you going to test your application? How are you going to make sure that your development environment is similar as your production environment? All this is very complex. So I give you an example of somebody who had this problem. So there's this show business star, or maybe Hollywood star, that created a game called Hollywood, where you try to climb the ladder of fame, like hiring an agent or going to the gym, buying nice clothes. And this is played by 23 million people. And when they had to face their scaling problems, so this person is Kim Kardashian, by the way. She has a game called Hollywood. And this was her face once she realized all the problems of deploying cloud applications. This was her face. So that's my joke for the day. Thank you. So apart from the joke, deploying application is a huge problem, and that's where Docker comes in. My 4-point bullet points definition of Docker, you think, what is Docker? How can you define it? Can you tell me one thing about it? I have to tell you 4, because I think Docker is many things, but it can be summarized more or less in 4 points. And Docker is a format. It's a new standard format in which you package your applications. That's one thing. Docker is an explicit declarative way to specify which ports, which file systems a certain application needs. And there's a way to link those applications together. Docker is also a caching mechanism where you can build on top of your previous work without having to rebuild everything else. And Docker also has a central registry where you can store or retrieve official packages or your own packages that you built previously. So you put all those 4 things together and you understand more or less what Docker is. And I have a couple more slides to explain you the difference. So Docker containers have been just exposed, put in place and compared to virtual machines. So Virtual machines are a very well understood mean to deploy applications in the cloud, and they work, and we have big platforms, and they brought amazing innovation, and they are a good solution. But whenever you deploy an application to the cloud, which might be just a few megs, you carry with you a lot of baggage if you use a virtual machine. You carry a virtualized Ethernet driver. You carry an entire operating system with each of your applications. That's a lot of baggage. And even though the performance penalty over time has reduced and reduced, it's still quite a lot of baggage and also a mental load of things that you need to think about. So here comes the Docker, which is, say, a small engine on top of your native OS, or even you can even run it inside a VM, and that isolates applications in their own namespace, in their own file system. They see the entire file system, but they actually have access to their own slice of the file system, and they boot up instantly. You don't need to wait for an entire virtual machine to boot up. So the experience of running Docker containers is really pleasurable. Everything, if you cached your images right, it's incredibly fast, and that's one of the powers of it. That's my 3 minutes. I don't know if I did it in 3 minutes. Okay, I think I did it more or less in 3 minutes. I'm proud of myself. So, plan for this session, now that we're done with the presentations, is I'm going to tell you why, as a developer, I am excited about Docker. And then we can share this if you tell me if you guys agree or not. I'll tell you some notes on workflows and techniques. So, the first thing I want to say is, okay, you excited me. I'm ready. What can I do with it? And then some techniques, or some common things you will run into and you will need to know so that you can start using it proficiently. And then some tips, some hacks, or some cool things you can do. And if you start building your own images, things you need to keep in mind. So that is the plan. Let's start from the why. So why Docker? And I have to pause and explain this picture. So the typical metaphor for Docker is containers, ship containers, big transatlantic boats carrying these standard containers. And I didn't want to use that, so I thought things that carry weight, and ended up in that weird place on Wikipedia. And that's what came out. It's the 18 mules team that used to carry borax out of the Death Valley at the end of the 1800s. And so the metaphor for containers in this talk is going to be donkeys or mules. Anyway. Why does Docker excite me and should excite all developers? There's a few things. Those are my reasons. The first one is it really caters to the OCD part of my personality, where I want everything clean, lean, and precise when I build my applications. So I think a lot of us developers have this compulsion. I want my application and all its dependencies and nothing else. And I want it to be reproducible. And it has to be beautiful and lean and clean. That's the feeling I get when I prepare my applications to run in containers. It's a beautiful feeling if you're OCD like me. But also if you are, want to have, it's a good thing in itself, even though you're not sick. The second thing is I regard development as a real pure act of creation. And creation requires inspiration. And if you wait too long to get to work on your idea, on your hack, on your feature, you might lose it. Or maybe it comes back later. But it's really important to be able to work on your thing as soon as possible, once you have an idea. And that's what Docker allows. If you have a standard image that you like to use, or if you want to start hacking on a cool project, on a new technology, you can just pull that image and start hacking on it right away. All the dependencies are provided. The time it takes to start is really fast. That is really exciting to me. Obviously, with this standard packaging format that I was telling you about, this gives you a lot of mobility and gives you a way to be very flexible on where you want to deploy it. So the famous promise that was of some technology platforms, compile once, run everywhere. We're not there yet with Docker, because Docker started only working on a specific Linux kernel version, and now it works on many more. And it used to work on just a few Linux distributions. Now it runs on basically all of them. But they're porting it. They ported it to ARM architectures. They're porting it to Microsoft Windows. So actually, Microsoft has announced a partnership to develop and make sure that their runtimes run inside Docker. So the promise of being able to move your applications across systems, across operating systems, is coming to fruition. And all big platform service providers, they're all embracing this. So they're all basically supporting Docker right now. So that's beautiful. And another fantastic pro is that there's two good things that are happening if you embrace containers. And that is developers can provide their operations teams with some really standard way, a deliverable that then operations can run with. Or because the barrier of entry into preparing your applications, linking them together, making your development environment closer to your production system, developers can take on some of the responsibility of operations and leave operations to the more complex, more complicated things that they do. So it's a very enabling technology. And last but not least, if you think about these fantastic buzzwords that we have been hearing at this conference also, and it is microservices. Everything should be a microservice. And it makes perfect sense because you can isolate pieces of your functionality and only provide one single service in one single application. And it's beautiful. And just the big example, right? The Amazon product page, which we as a consumer see as a single page. It has hundreds of microservices for product reviews, pricing, discounts, and all sorts of tiny parts of that page come from different services. And this matches fantastically well with what Docker can do. You can isolate your small API exposing REST endpoints for tiny bits of your application in containers. And it's beautiful when it works right. So those are my 5 reasons. And then we can talk later if you have other ones or if you disagree. That's nice too. So now that I told you a few reasons why that excites me, maybe you want to know, okay, so what do I do with it? How do I use it? And I'll give you a few. And obviously, there's a main one. There's a big elephant in the room. Previously, I saw a talk where there was a big elephant. I missed my opportunity there. So the big first use case that you can start thinking about, and you can start small and then expand, is obviously as a developer, once you're ready with the release of your application, you're relatively ready to deploy it, you can just try and start packaging it inside a container. And then make sure you explore which platforms can host your containers and run it in the cloud. That's simple enough. That's the most basic case, things that you can do. But there's many more, as a developer, things that you can do with Docker. So for example, one really useful thing, and I think everybody here would like to try and do that, is pick your technology stack. Maybe it's Java, maybe it's Ruby, maybe it's Go, and create a base image that contains all the libraries, all the tools, all the dependencies for your platform stack. And then you can build on top of that. So that is a very common use case, and everybody who finally embraces Docker ends up doing this. And it's very cool. Another way to use Docker right away as a developer when you're experimenting or working on your project is you keep your code in your host operating system and you change it there. And then you build your container. You do this cycle of code, build, test in a container repetitively. And your Docker build file, your Dockerfile, and we'll talk about it later, just pushes the new code inside. And this creates a really fast loop. And the good thing about it is that the package container you get, the image you create, can be as easily then pushed anywhere else where you want to run it. So you get a really big sense that you can test in your development a setup that's very close to your production environment, which is nice. There's a few more. For example, if you guys are working on a tool that needs to work with different versions of your software, like something that needs to work with Java 1.7, Java 7, Java 8, or Ruby 1.8, Ruby 1.9, whatever, you can create images, base images that have those requirements, and then deploy your application inside those and test if they run. And if you create your images right, this loop becomes incredibly fast. There's a whole category here of activity and for which Docker is really well-suited, which is continuous integration, continuous delivery. And we ourselves, we have a build server called Bamboo. We're working on embedding, Docker containers inside our products. So there's a whole lot to talk about here. Just by itself, it would be a different talk. There's another quite interesting pattern, which is imagine you have this tool that you want to install on your system, but you're not really sure if it's going to go and change something in etc or wherever it's going to install, and what's the process of installing it. You can just test your installation of this specific library or package or platform first in a container and make sure that you understand what are the requirements, the dependencies, and the changes. That's a cool thing you can do. And there's another one, which probably is like another of the big elephants in the room, which is there's a library of tens of thousands of official packages on the Docker registry that are, in the public. They have a public Dockerfile that you can inspect, and you can understand how those libraries have been and platforms have been created. And you can just pull them as a starting point for your projects. And that is very liberating. It gives you that speed, that getting to work in a really fast process that I was telling you about. So those are some of the reasons, some of the things that you can do as a developer. And the next part is about some basic techniques. So when you start working with Docker, you need to have some basic building blocks that you need to know so that you can use it profitably. And the first one is you have to know a little bit about what the Docker files are. Who has already written a Docker file? Okay. Okay, I'll say 15% of you, maybe a bit less. So it's good that I tell you what they are. So a Docker file is, say, a build file for applications running in containers. It's like a build script. It's like a shell script. And it looks like this. And the key point is that you can inherit from a previous image. That can be an official one. It can be your own one. And every step in the script, most steps in this script are cached. And so that means that you can build incrementally your applications starting from more generic requirements to actually deploying your single specific application by building a Docker file properly. And it works like this. So every time there's a run command or a copy command or an add command, actually what Docker creates, Docker uses a copy on write file system where each run command creates a new snapshot, a new image on top of the previous one. So if you, for example, use Debian and you update the packages, that creates, those changes are created in a specific layer on a copy and write operated file system. And then you install the packages that you need. That is also created in a separate layer, if you do it that way, if you do separate run commands. And then if afterwards you want to clean and make sure that all the things you have, the debs that you have downloaded are deleted, they will be deleted only in the innermost layer. And so you have to be careful how you structure your commands, because otherwise your images will explode. So I'll talk to you about some tips about optimizing your Docker files, obviously, later. And before we go that, I want to tell you another of the principal techniques of building Docker files, which is what I call this fantastic name I came up with, which is the add plus build routine magic, which is just a very silly way of saying there's a Docker command, which is add, and you can also use copy, that moves the stuff you have in your host OS inside of a container. It's like one of the chief ways for you to add code of your application to your code to the application. And so I recommend that you leave that command last. So for example, a process might be you pull the latest changes from your application and you do the changes locally outside of Docker in your host VM, and you build your application again with the Docker build, and you leave the add statement at the end. And this will reuse all the steps that you have already created with your libraries and only add the new code at the end. So this will make sure that building those images is going to be really fast. That's a typical thing. It's not too complicated. I just mention it because when people start creating Docker files, they don't really know how to organize them. So it's something to know. Then another basic thing that you run to right away, as you start creating your containers, and you hit it as soon as you want to use more than one container, is how do I share data between containers? So one basic pattern that has emerged recently is what is called a data-only container. So the way that you share containers between the host operating system and Docker is by using a volume directive. So in short, the shortcut is -v or -v, where you specify, I want to mount this specific folder outside of the host VM, and I want it to be called like this inside the container. The command is actually like this. So when you run a Docker run to run a certain command, you can specify -v with the volume that you want to mount. That's easy enough. You can also specify that a certain container, when you're in a Dockerfile, exposes a certain volume by using the volume directive in a Dockerfile. That's relatively simple. So what was that data-only container I mentioned? Well, containers don't necessarily need to be running. So that's one thing that you need to know. So one way to share data or folders between containers is to create a container that exposes some volume and doesn't do anything else. It's actually not running. And other client components, client containers will mount those volumes, that data container. So to create a volume-only data container, you just give it a very short command like true that starts and exits right away. And you just specify that that container has some volumes, and you give it a name. So --name data, we call it in this example. And then what you do for the other containers that need access to those volumes, you use a directive called volumes from that will allow you to mount the containers in this data container very easily. This works, by the way, if all your applications, all your containers are running in a single machine. And now you might wonder, yeah, but we're talking about distributed application, microservices. This might run in multiple machines. And we'll get to that. But first, let me show you as a command how that works. So when you have a certain client container application and you want to mount a data container, you use the volumes from directive. And that will allow you to access those folders automatically. So going back to the question, how do you share data or folders across the border of multiple machines? We have solved this problem for many years, and it's a solved problem, and it's not very much different when you use Docker. And that is, you can use any network storage protocol that you like. You can use NFS, you can use Samba, you can use any one of those. And the good news is there's official images that support those. So if you want to set up a simple NFS file sharing system across the system, you can just pull the NFS image, set it up with some parameters, and then all your containers can access those folders. That works relatively simply, and it has a high performance. You can do that with Samba. You can do that in many ways. The other thing that you run into as you start to create your application and linking them together is how do I actually link them together? So there's a facility called links, and I have to warn you, it is being rewritten right now. They're working on a next generation that gives a bit more low-level control about the net masks and the IP address. But right now, the way to link containers is to use the link directive, and it works like this. So imagine you have a certain client that needs to access a PostgreSQL database. And the way you do it is you just tell the client that it will have a link, the client container, that it will have a link to some database. And you give it, the first part is the name of the actual container that contains the database, and then after the column is the name that you want to give it inside the container. So imagine you're building a container that contains your PostgreSQL database. You do docker build minus the PostgreSQL dot, where you're building your database container. And then what you need to remember is to give it a name. In this case, I gave it the name PG. And then when you want to run a shell that connects to that container, you just link it. So you say, OK, container name PG, inside my container is going to call PG. I've been very creative there. And then inside it, you can refer to that host. So what the linking facility does actually goes inside the etc host file of the client container and changes and sets the name up to a P address mapping for you. So that's the simplest way you can do container linking. There's a lot to talk about orchestration and coordination of containers, but maybe that would be for another session, or we can talk about it later. Okay, so let's talk about some tips and hacks. Once you have these building blocks and you're excited about using it and you start linking your containers, there's a few things you need to know so that you create nice, concise, lean images. So I'll give you a few ideas. The first one is a high-level concept, which is not too hard, and I'm sure you already know it yourself. And that is, as you build your images, try to put the more general statements first and the more specific statements about your application last. Very simple. This will allow you to reuse some of the steps in your cached container images when you develop another application, or if you want to iterate and rebuild your application at a later stage. So imagine you installed all the Java dependencies you need, and then you keep adding new code to your application. All the steps about installing Java will already be taken care for you. That's nice. So relatively simple, and it's close to the add plus build routine magic that I told you before. So another important thing that I want to mention is when you start depending on images to build your applications, mostly the default one and right now is the Ubuntu one. But if you look at the sizes, if you guys use Ubuntu, the base image is around 195 megs, while the Debian one is only 85 megs. So unless you have a very specific requirement to use Ubuntu for your applications, consider saving 100 megs right off the bat by using Debian. Sometimes that's not possible because you have a very specific requirement of using a specific distribution. But please check how efficient are or how big are your starting base images. The other tricks are all these next steps go a little bit together, and that is try to avoid generating temporary files as you create your Docker files. Because, as I said, every caching step will be saved. And obviously, if you use a package manager, you want to make sure that at the end of the steps you clean up after the package manager. And by the way, about removing temporary files, I'll give you an example. If you're downloading a zip file or a tar file, and then you are unzipping it, and then you are removing that specific tar file because you don't need it anymore, all those three steps should be a single bash command using end-to-end or pipes. And that will save you, like saving the file in a slice snapshot and then removing it in the next one, which will actually not remove it. So as much as possible, try to combine commands as you create your Docker files. So I'll give you an example of what that means. Very simple. I want to get the latest updated packages from my Ubuntu distribution. Then I want to install some requirements I need, in this case, some Python stuff. And then I want also the official Node.js maintained latest Debian package for Node.js. And then I want to re-update the debs so that I can actually install it. So what I did, I just added a pointer to the latest packages of Node in the third step there. If I do this, I will create a lot of snapshots that will add stuff. And the way you want to do it actually is to run everything in a single run command. That will create a single snapshot that will create a container that's reusable and as lean as possible. So it matches very much just shell commands, and try to couple them with end-to-end and pipes whenever that's convenient. If you're not sure about what's happening, and then if your images are exploding, I show you a way that you can do to check what's happening. So for example, you can very easily inspect the space used by your images, and then just use the history command. So it works like this. You just type docker history, and the image that you just built. And it will tell you and show you the size of each of the commands that you ran. So if you see that from one step to the next, you have exploded up 500 megs, you can go and check if that's exactly the most efficient way to do that. Another very useful thing as you try to optimize your images for efficiency is a flag called tree that allows you not only to list the images that you have downloaded locally and that you have created, but it will create a tree-like structure. And with that, you can see the dependencies and how you're branching off in multiple applications, multiple versions, different save points, which can be useful to make sure everything is efficient. Sometimes it's nice to, when you inherit somebody else's image, he might have cached points in the image that you don't really need. So say you need a Node.js official repository, or you want to start from Ubuntu 1, and that's the one that you're going to keep. And then you inspect it, and you see it's actually 3 snapshots, which you don't really need. Or yourself, you have created an application, and it is in 5 steps. But then when you want to transfer it, you just want to make sure that it's one blob and it's ready to be deployed like that. So there's a trick to do that, which is to flatten images. And the way you do it is to export. You export an image and then you re-import it. And this will basically collapse all the file system layers into a single one. And it's a neat trick. So the result of exporting a certain application, you pass it the ID, and then re-importing it, reading it from standard input, and tagging it however you like. In this case, I use the stripped tag, and then that might not save you, will not save you space, but will give you a good feeling to having a single snapshot for it. There's another trick which is really cool, and then it comes up many times. And I'll make an example with Ruby, but it works for very many applications, very many frameworks like Node or a few others. And it is a trick to cache your dependencies, which the ones that have already been experimented a lot with Docker, I'm sure you definitely ran into this. So as I told you, when you want to add your code to a container, you generally use the add statement or the copy statement. So the difference between add and copy is that add will unzip a file. If you have a local file that is tarred and gzipped, when you add it inside the container, it will explode it automatically, while the copy command will not. But anyway, as I mentioned it, this is a step where you're adding your code to the container. You specify that that's going to be your working directory when you run things inside the container. And then, if you guys know Ruby, you can use bundler to collect your dependencies and build them. Now, if you do this, what happens when you change just one line in one of your source files? Not your library files, but your source files. Well, I tell you the answer. What happens is you lose all that bundle install step, because the add step will not be able to use the cache anymore, and everything will be rebuilt. So that obviously is not nice, because you want to do this really tight loop of rerunning your application and rebuilding it really fast. If every time you have to wait 1 minute, 2 minutes, 5 minutes for rebuilding all the dependencies, what's this fantastic efficiency that you were promised me, Nicola? Come on. I don't like that. Show me how to do it. Okay, so the way to do it is a trick, and that is you temporarily move the working directory somewhere else, and you add the actual relevant files for your bundler, your gem files somewhere else. So you add them separately. So if you add them separately, and then you run the bundle install, those steps will be cached until you don't change your libraries. And then after that, you can add your source file. So then every time you change now, if you change in this alternative scenario, if you change a line of your project, the dependencies will not change, and that application will be rebuilt. The new container will be rebuilt really, really fast, which is very nice to do. And as you guys play with it, you will see how it can give you a very big boost in efficiency. Another cool thing that I wanted to bring up is a trick, and that is, so the Docker container runtime, very efficient. Wouldn't it be nice if you could package an application with all its linking statically, with all its dependencies in a single binary and run that? That would be cool, right? So, and actually somebody has managed to do it, and it's especially easy for languages that allow you to obviously statically link binaries. And the savings in space are amazing. So the way to do it, so for example, if you experiment or use Go has the possibility to compile the application down to a single binary, statically linked, that doesn't require not even glibc. And so those applications then become really, really compact. How do you do it? Well, the trick is to use a base image, which is called the scratch. And the way you create this scratch image is you say, okay, I want to create an image, and what I want to import is an empty tar file. And so that works like this. So it's this Unix command that allows you to create an empty tar file, and then you import that into Docker as an image. You don't really need to run that command. You can just do from scratch, because it's actually an official base image you can use, and that's the smallest you can have. And if you now have a binary, which includes all its dependencies and statically linked, you can just add it and specify that that's what's going to be run once you start it. So the savings of this, if you do, an example I saw, and actually it's linked in this deck. Yeah, it's like a 10x change in the size of your applications. Why would you do this and not just use a binary file? That might be one of the objections. Well, if you package it inside a container, you get all the benefits of the portability, of handing over a container or an image to somebody else that can take care of it, of platforms that are ready to take your applications and run with it. So there's a lot of benefits of using this pattern, even though you can do it yourself. And finally, I want to give you a sense of where Docker is going, because, okay, these are things, the things I showed you are things you can do right now, and there's quite a few companies deploying Docker at full scale. There's one that does bespoke WordPress deployments that has millions of containers, and each container contains like a WordPress deployment. There's a lot of hype. Every platform as a service is now embracing containers, but the ecosystem is moving really fast. So they're about to announce a few innovations. They've already been announced, but the actual 1.0 version of these tools are coming up. And I want to just give you a sense of what's coming up and why that's even incredibly exciting for me. So they're coming up with 3 new tools that are embedded inside the Docker ecosystem. So one is called the Docker Machine. And what Docker Machine does, it allows you to provision a Docker system either locally or on any PaaS provider with just a single command. So you can do Docker Machine create local, and if you're on a Mac, it's going to create a boot to Docker tiny core Linux image ready for you to use to run containers. But if you do Docker Machine create rack space and a few API keys that are for your user account, you can deploy and have up and running Linux distribution with Docker running in a few seconds. And the same is true for DigitalOcean and the Google Cloud. And so they're working on, and obviously it's a pluggable architecture, and you can provide your own PaaS interface to it. And this is very nice to get up to speed and also try the performance of different providers out of the box. Another one which is really exciting for me is Docker Swarm, which is a clustering solution for Docker containers. And what is interesting about it is that it's a declarative approach to clustering management, where you say, this container, I don't really care how you do it, but it needs 2 gigs of RAM, it needs access to this amount of drive, it needs to run on the East Coast, and I would like it to have a priority for CPU. You describe what you need declaratively, and then in another place you describe your infrastructure. I have X machines or X bare metal machines with X RAM or X virtual machines. And Docker Swarm manages balancing, deploying, restarting. There are restarting policies. And it's beautiful. So if you haven't looked at the demos, I encourage you to check that out. It's not out in production like 1.0 yet, but there's prototypes that you can use now. And Docker Compose is that part of the framework that allows you to orchestrate and declare how components and applications should be linked together. So I showed you before how you can, with a link command, link a few components together. As the number of containers you run grows, that becomes harder and harder to manage with just a command line. So Docker Compose is an evolution of the Fig framework, which I actually have here, which it's already out there, it's already perfectly usable. That allows you to declaratively describe this application requires this other container that needs to run on this port, and I would like you to mount this. So it's a way to declare and orchestrate your containers. So the sense I want to give you, and I started with an elevator metaphor and about everybody dying, and instead what I want to give you a sense, I want to give you a sense of an ecosystem that's exploding with ideas, exploding in activity, and I really think it will bring like the ability of us deploying applications in the cloud one level, one step higher, one step easier. And so I'm very excited for the future of Docker, and I hope after this you are too. And with this, I thank you very much. Hey, there you go. Thank you. If you want to tweet at me what you didn't like or what you liked, you are the end. And I think we have 8 minutes.
Yeah, 8 minutes for questions. So please, raise your hand.
Somebody's there.
Hey.
Hi.
You said that the Docker instructions, if they were run already, they basically are skipped, something like that?
Yeah, so if the result of a run operation, of a run command, creates exactly the same result, then that step is skipped. No, sorry, it's not like that. So that is only true for the add and copy commands. So it will, the add command will first check like the checksum of the tar gzip content of the files you want to add, and if those are the same, that will be skipped. Otherwise, the run commands are tagged, and those changes are cached into this copy and write file system, and will be reused.
But they are still run, right? Because my problem here is that if you do apt-get update,
yes.
I mean, updating today will not have the same result as updating tomorrow. So because package updates and stuff like that. So if you just cache.
Yeah. So the way to do that is to be very specific and pin in packages. If you want to make sure that. If you want to go into the versioning part of it, you can actually pin, with apt, you can pin the packages that you really want, so that the dependencies don't move while your application, still needs the old ones. No, everything is cached, so the apt commands will not be rerun unless. Okay, you managed to confuse me. Yes, there is obviously a cache, and you can specify if you want to re-execute all the commands. Otherwise, if those are marked as executed, they won't be re-executed. Yeah, thank you for.
Oh, damn! Oops. Thought no one would hear me. I'm wondering if Docker does anything to different. Processor architectures or doing any binary fiddling.
So Docker used to work only on 64 bits architecture. I think right now that limitation has been lifted, but you should stick to one architecture, I think, and not mix and match. For example, just to give you even a broader sense of this, so Microsoft is working on porting, making Docker run into Windows 8. That doesn't mean that if you build a Windows application and you store it in a container, it will run on Linux. You will need a Windows runtime for it. Still, you will be able to use the same commands and the same infrastructure, but you will need obviously to package and have a Windows at least base image. So, yes.
Another question: you can have an add command, which, well, say my problem with having images a bit too big is that I add something, say the installation script. I add it and I run it within the Docker container. So in the end, I get this binaries essentially twice. First, the original source installation package, and then the actually installed stuff.
Yes.
Is there some nice way to avoid this?
Yes. So I showed a few, but so one is try if it's a shell command that you run or Python script or whichever, trying to have one command that does both. So now I know you cannot add the add command is a separate statement. So yeah, so one alternative is to have everything generated outside of the container and then push it in a single add command. That's one way. And yeah, so when you need to do add and then run the build in container, one trick that I showed you is the one about trying to have the build one as high as possible. But this add setup, I understand your problem, and I have to think about if there's a more efficient solution. One I can think of is do that build outside and then just deploy inside the result of it. But it might not be as clean, but that's one way.
Okay, still room for a few questions. Anyone? Okay. Oh,
somebody there?
There, someone there.
So I'm basically wondering what's shared with the host system, and yeah, what can you see and use of the host system?
Yeah, so if you do a PS inside a container, what you will see is that only the application that you're running inside the container is running. So the container itself thinks it's running, it has the entire system by itself. And also the container itself thinks it has access to the entire file system, while it's just a copy and write file system where any modification that the container makes is only private to that specific container. Also, there's a juggling and managing of opening ports. So the container is very constrained. You specify which ports any container is allowed to communicate with. So I don't know if that answers. Those are three things that are happening. So the container itself thinks it has access to a whole system. It thinks it has access to the entire file system. And
okay, so a second question there. So basically we're still loading shared libraries twice into memory?
Yeah, so good question. One thing I know for sure is if you use, for example, inherit from an image that has a different distribution, you still get the kernel of the engine outside. So, for example, if you use, on a Mac, you use boot2docker, which uses a tiny core Linux distribution. It has a specific kernel version, 3.18 tiny core. And even if you do from Ubuntu image, you will get a runtime kernel, which is the one of the host operating system.
Okay. More of the question of... no, sorry.
Okay. Other things?
One last question. Anyone?
All right. Thank you very much, guys. Thank you.